Hello friends! In this video, we are building multimodal RAG system retrieval augmented generation using Weviate as our vector store and ImageBind model from Meta AI to embed our data. In my other video, I already showed you how to build a text-based search for a video content. And in this video, we are going beyond that and we are adding audio and images as modalities. So the idea is to ask the system where exactly this image, audio, or text occurs, and as a result, it returns the exact content, timestamp, and video ID. For this prototype, I used 4 videos, 2 videos from my YouTube channel, 1 video that I used for previous video on RAG, and I created video to check audio to image mapping. For interactive exploration of results, I built Gradio application so we can just go and test it together. In a Gradio app, you have 3 input fields for each of the modality, one for text input, image input, and audio input. Once you submit it, you can click the search button, and as a result, you're gonna get 3 responses for each of the modalities: text result, image, audio, together with the metadata that contains timestamp and video ID in which this content occurs. When given image of cute little lion cubs as an input, we can get very good results for image modality and text. Not very good results for audio, I would say. First and second responses are quite far, although last one is pretty good. My favorite example is this. That results in a very good image response, not so good for text, and it's expected we will talk about this later. Very good first audio response, quite relevant second one, and as you can see, every result comes from the metadata like similarity score, video ID, and timestamp. When asking to find coding piece, it does a pretty good job, although, yeah, we can argue about accuracy. Now let's build it together. To get there, we first need to understand what is ImageBind, how it works, what it does, and what are its limitations. Second, we need to understand what is Weviate Vector Store, what is general pipeline in order to spin up Vector Store. Third, we need to combine ImageBind and Weviate to create multimodal vector store. Fourth, we need to extract data, different modalities, audio, image, and text, and prepare it to feed into vector store to make it searchable. Finally, we just need to go and query our vector store and test its results. In 2023, Meta released ImageBind, a model that pushed the boundaries of multimodal AI. Instead of learning just from text or images, ImageBind brings together 6 different types of data. It's text, of course, image, video, audio, depth, thermal, and motion (IMU) into one shared embedding space. The idea is simple but powerful, but using images as a common anchor, ImageBind learns to link how something looks, sounds, feels, and moves. For example, it can associate a picture of a lion with its roar, body movement, and even heat signature, all without explicit labels. There is a GitHub homepage where you can find the model and how to use it. ImageBind has so-called emergent capabilities, like multimodal search that we're gonna use for our prototype, few-shot classification across modalities, embedding space arithmetic, which is pretty cool. You can even query with arithmetic, and generation of images from audio. Importantly, ImageBind also supports direct video embeddings. No need to split into frames or extract audio manually, but we're still gonna do it in this prototype. Tools like Weviate now integrate these, letting you build vector indices across text, images, audio, and video with just config. But it's not without limits. ImageBind doesn't handle direct text-to-audio mapping or precise transcription, so we still need to use something like Whisper for our prototype. And Modal's card says that it's not ready for production use because it can have some biases or produce unsafe associations if misused. Weviate is fast, production-ready, and packed with features: built-in vectorization, multimodal search, hybrid queries, and native support for tools like OpenAI, Cohere, Hugging Face, and ImageBind. Self-hosting is free and open source, and for managed cloud, you pay based on usage with a free trial to get started. It scales from your laptop to the cloud, run locally via Docker, embedded mode, or deploy at scale with Kubernetes. It supports multiple clients, including Python, JavaScript, Go, Java, TypeScript. The general workflow is pretty straightforward. First, you pick your setup, local, cloud, whatever. Then you connect to it using one of the client libraries. You create your collections. It's like a classes in programming language. Load in your data, often in big batches, and then you're all set to fire off those multimodal queries. I'm running Weviate with Meta's ImageBind locally, all inside the Docker setup. To set this up, I used Docker Compose file, and I found it in Weviate documentation and customized it a bit. So it launches two services, one for Weviate and one for ImageBind that creates multimodal embeddings. Now the cool part is how they talk to each other. Weviate needs to call ImageBind when it needs to vectorize something, image, text, audio, but not the other way around. So in our Weviate config, we tell it bind inference API and give it address and a port, and that's the link between the Weviate and ImageBind. Notice how I'm also exposing port 8081 on the host, mapping to 8080 in the multi-2vec bind container. I'll be using that later when we send audio queries for embedding. We'll get to that in a bit. Once that's set, just run docker compose up, and you've got a local multimodal search engine ready to go. Connecting from Python is straightforward. So we first import Weviate, where we connect to client and we close it. And I created Weviate multimodal class and moved all the code that's relevant under this class, and also created methods like connect to client and close client. Now let's talk about the collection. Weviate stores data in collections. A collection is a set of objects that share the same data structure. My collection has following properties: text, image, audio, media type, video ID, and timestamp. All of these can be embedded into the same vector space using ImageBind. That's what makes multimodal search possible. Here is how I configure the vectorizer. So first argument is EF construction. When you store embeddings, for example, from text, images, or audio, you want to be able to quickly find the most similar ones to a new query vector. That's what vector indexing enables. Weviate uses the algorithm called HNSW to build a graph where each vector connects to its most relevant neighbors. The EF construction parameter sets how many candidates it considers when adding each new vector. So EF construction equals to 100 means when inserting a new node vector, look at up to 300 possible neighbors before deciding which to link. It doesn't define the number of final edges, just the search scope during indexing. Higher value and you'll get better quality graph, higher recall at a query time, And with lower value, you'll get faster indexing, but potentially worse retrieval. And for multimodal RAG case, where semantic accuracy matters more than index speed, 300 is a solid choice. Distance metric parameter. I chose it to be cosine, and here is why. When comparing embeddings, text, image, audio, we need a distance metric, and we're using this because it looks at an angle between vectors and know their length. Two items pointing in the same direction, this means the same thing, right? Even if one is louder, longer, or bigger. And another very important parameter is filter strategy, and I chose it to be sweeping. This determines how Weviate preselects candidates for vector comparison. If during querying we add filter like video ID is equal to multimodal AI, Weviate needs to decide when to apply the filter, and this affects the result. So without sweeping, Weviate performs a broad vector search first, retrieves k nearest neighbors, and then applies the filter to the result set. So if many of the top k vector neighbors don't match the filter, you might get fewer than k results, and they might not be very good. With sweeping, Weviate attempts to be smarter. It might pre-filter candidates based on the filter before or during the vector search. The term sweeping implies it might iterate or sweep through potential candidates, checking if they match the where filter, and then considering their vector similarity. This ensures that the final results are the nearest neighbors among those that also meet the filter criteria. Since our input is a video and we want to search using text, image, or audio, we need to extract those modalities first. Extracting images. I use a function called extract images from video that takes video input path to the input video output path, where to save frames plus metadata about these frames, video ID, a unique ID for naming files, and frame interval, how often to extract every 10th frame, etc. And display frames is a parameter for whether to visually preview frames. I use OpenCV. First, we create CV2 video capture object. Then we loop through the video, grabbing frames at intervals. We skip blank or solid color frames. For each valid frame, we save the image as JPG and store metadata like ID, timestamp, and write status. Finally, we write all this into a CSV metadata file. Extracting audio is very easy. I use a video file clip from MoviePy to pull it directly from the video. For text, I use Whisper, covered in details in my other video about RAG. We load a small model, let Whisper auto-detect the language if not passed, then transcribe the audio into plain text and timestamp segments. Before we can add anything to the vector store, we need to format our data. Each entry should be a dictionary with fields matching the vector store schema: path, image, audio, text, media type, video ID, and timestamp. For text and audio, we first chunk the data to keep context manageable, and then we encode image and audio as base64, since Weviate expects binary data in this format. Once all dictionaries are ready, we are set to upload. I use a method called batch insert items that I built. It takes the list of dictionaries and efficiently loads them into Weviate in batches to avoid bottlenecks. And that's it. Your data is now indexed and ready for querying. Querying Weviate is straightforward. It supports multiple search methods: near text for text queries, near image for image queries, And while there is no native near audio, we handle it using near vector. For audio, I extract the embedding first using ImageBind. That's why we expose the ImageBind Docker port, so our Python code can send a request to localhost/vectorize. To keep results clean, I apply filter by property media type like and whatever output modality we want. This ensures the results match the expected modality. For example, don't return text when we query with an image. Without this filter, Weviate sometimes returns irrelevant or mixed modality results. For instance, an image query might return only text results and not very good ones. You can also pass a list of properties you want in the response. Weviate returns objects with vector similarity, and each result has properties, the actual content, metadata, useful details like distance between vectors. That's how we query and control the results across text, image, and audio. Thank you for watching, and I hope this gives you a solid starting point so that you can build your own multimodal RAG system quickly and confidently. You can find the full code on my GitHub page and link in the description. Please feel free to leave any comments, feedback, or share idea that you want to explore. See you in my next videos.